We'll be going over polynomials pre-assessment, the detailed answers. We'll be doing addition, subtraction, multiplication, and division. So when it says simplify, and we see that we have 4 terms here, we're going to combine like terms. So just a reminder, like terms have the same variable. They have the same variable. Now notice all of these, and we always look at the first variable of each of the terms, they all have the same variable. So does that make them like terms? No. Now, since they're tied with the like variable, like terms have the same variable to the same exponent. So these would be considered like terms. And when we combine like terms, we're going to combine their coefficients. So those other a's are a to the third. And these are like terms because they have the same variable and exponent. So we will be combining these coefficients. So these attach to those, and color, and this attaches to that. So let's combine those. We have 5a squared and negative 4a squared, which makes a squared. We have 7a cubed minus 8a cubed, which gives us negative a cubed. Notice I didn't write a negative 1. We just don't write, and I didn't write a positive 1 here. And now we have to remember to put it in standard form. So standard form, we always are going to go alphabetical order. And then when we tie, much like in this case, they both have a's, we're going to use the one with the bigger exponent. That's always going to go first. So we would write our answer as negative a to the third plus a squared. Students tend to make a mistake here. That's our answer. And the way that they write the mistake is they forget to include that negative with the cubed. And remembering that this is positive 1. So when we rewrite it, that has to come and that has to be together. That's a positive. So we would rewrite it in that manner. Okay? So just keep that in mind. Let's look at number 2, like terms. We have n squared, and there is no pair. That's a good example. We have n to the 4th, and it has a pair right there. And then we have n to the 3rd, and that doesn't have a pair. So the only ones we're going to combine coefficients are negative 8n to the 4th and negative 6n to the 4th. Negative 8 and negative 6 makes negative 14n to the 4th. Then we'll put them in numerical order based upon their exponent and their variable. So we have 7n to the 3rd, and we have negative 3n squared. So that is in standard form. N to the 4th, and n to the 4th, n to the 3rd, n to the 2nd. So notice variables are tied. They all have n. So we had to break the tiebreaker. We go to the exponent. And question number 3. Let's find like terms. So I always just start with the first one. That's going to match with that x to the 1st. This is x to the 4th, and that will match with that x to the 4th. Now we're going to look at their coefficients. We have negative 4x, positive 2x is negative 2x. We have a negative 2x to the 4th, positive 7x to the 4th makes 5x to the 4th. We're just combining their coefficients. Now we have to make sure it's in standard form. This is x to the 1st. This is x to the 4th. So we're going to write x to the 4th first. 5x to the 4th minus 2x would be standard form. That's our answer. We have x squared, no partner for x squared. We have a constant, which has a partner, and then we have 2x, which also doesn't have a partner. So it's going to be negative 5x squared plus 2x, and then it's going to be minus 4. We're going to combine those constants. The other two terms do not have don't have a partner or a like term. We have m to the fourth, m to the fourth. We have m squared and m squared. 7 and negative 3 makes 4m to the fourth. Positive 8, positive 3 makes positive 11m squared. Number 6, let's find its likes. That's a constant. That's a constant. This is a v to the first. That's a v to the first. That's v squared and that's v squared. So let's combine them. 5 and negative 8 makes negative 3. Negative v and negative 8v makes negative 9v. Positive 5v squared, positive 8v squared makes positive 13v squared. Now we're going to write it in standard form. V squared is going to come before v, and the constant is always going to be last. Be careful of those negatives. Keep the negatives with the original number. When we look at this line, notice we've got a positive 13v, a negative 9v, so it has to stay negative 9v. A negative 3 has to stay negative 3. Positive 13v squared needs to be positive 13v squared there. Constant, constant. X, and x to the fourth, x to the fourth. 6 and 7 makes 13. 2x and 2x makes positive 4x. 8x to the fourth minus 7x to the fourth makes positive x to the fourth. Notice again, I didn't put a 1 in front of there. It's understood that there is a 1 in front of it. Plus 13. And then we would write it in standard form. Number 8. Like term would be x to the fourth. X to the third, like term. X squared doesn't have a like term, and x doesn't have a like term. So we're just combining those two and these two. Negative 6x to the fourth, negative 7x to the fourth, negative 13x to the fourth, negative 8x to the third, positive 7x is negative x to the third. I don't write the 1. Negative x squared and positive 5x. And that is in standard form. X to the fourth, x to the third, x to the second, x to the first. Pairing them up, 8r, negative 8r. Ooh, that's a good one. Negative 3r squared, positive 3r squared. That's a good one. 6r to the fourth and 6r to the fourth. Those are like terms also. So we're going to combine those. We're going to combine those. We're going to combine those. So 8r and negative 8r, they cancel to make 0. They do not cancel to make r. That would leave us with 1r. And 8 and negative 8 make 0. Negative 3r squared and positive 3r squared, that also makes 0. Positive 6r to the fourth, positive 6r to the fourth makes 12r to the fourth. That's not a very good 4. To the fourth, and that would be our answer. Number 10, you've got negative x, or you got x to the third, x to the third, you got x to the fourth, x to the fourth, you've got constant and constant. Negative 3x to the third and negative 2x to the third makes negative 5x to the third. 4x to the fourth and 7x to the fourth makes 11x to the fourth. And they have negative 5 and positive 5, which makes 0. Let's put it in standard form. And there you go. Number 11, we have m squared. We have m to the third and m to the third. And again, we've got our constants in the middle there. So negative 5m squared, negative 6m makes negative 11m squared. 5m cubed plus m cubed is 6m cubed. There's a 1 in front of that. So 5 and 1 makes 6. And negative 1 and positive 2 makes positive 1. Let's put it in standard form. And we are good. Last couple. I think we go up to 15, I think. 8v, 5v, 7, and negative 2. Negative 4v squared, positive 5v squared. And that gives us 8v and 5v makes 13v. 7 and negative 2 makes positive 5. Negative 4v squared and positive 5v squared gives you positive v squared. V squared plus 13v plus 5. Hopefully these are getting easier now. And you're like, yes, I got it. I understand this. This makes so much more sense. If I do all these for practice, it makes it so much easier. The more familiar you are with this, the simpler it gets. And you become familiar with work through practice. Negative n positive 4n gives me 3n. Negative 4n and n cubed, 7n cubed gives me positive 3n cubed. Negative 5 and negative 2 makes negative 7n squared. And because I did those lines, it's easy. All I'm looking at are the coefficients at that point. I already know what the variable is going to be. Let's put it in standard form. Number 14, let's pair them up. R and R. R cubed and R cubed. R squared and R squared. So negative 4, negative 3 makes negative 7R. Positive 6, positive 5 makes positive 11R cubed. Negative 2, positive 1 makes negative R squared. Standard form. And number 15. We got X. We got X. We've got X cubed. X cubed. We have X squared. X squared. Negative 2 and negative 2 makes negative 4x. Negative 5, positive 8 makes positive 3x cubed. Positive 4, negative 2 makes positive 2x squared. That gives us 3x cubed plus 2x squared minus 4x. All right, now multiplying. This is where you have to be careful about all the little steps that you were just doing and understanding that multiplication is going to be a little bit different. So this is just like 3 times a squared times 7 times a squared. And we're going to multiply the 3 times 7 and the a squared times a squared. And we're multiplying the a squared times a squared because they have like bases. Not because they're identical. They happen to have the same exponent, but only because they are identical bases. When you have like bases, that's when you can combine them. So we have 3 times 7, which is 21. And now, because we have like bases, when we multiply like bases, we add their exponents. So you get 21a to the 4th. As you'll see in this one, This is just like 6 times x squared times 8 times x cubed. You're going to put the constants out in front, and then you have x squared and x cubed. Because they have like bases, we're multiplying, we're going to add their exponents. 6 times 8 is 48, x to the 2 plus 3, which gives us 48 x to the 5th. Next one, 3 times b to the 4th times 5b squared. We're going to take those constants. We're going to multiply. Whoa. They have like bases. And we're multiplying, so we will add those exponents. 3 times 5 is 15. B to the 4 plus 2, 15b to the 6th. 8 times b times negative 3 times b to the 3rd is 8 times negative 3 times b to the 3rd. Now this is where students, 8 times negative 3 is negative 24. That's the easy part. But this is b to the 1 plus 3. There's an invisible 1 here. So we have to represent. It has to have a value. Negative 24 b to the 4th would be your answer. 7 times m times negative 6 times m to the 0 is 7 times negative 6 times m to the 1 times m to the 0. 7 times negative 6 is negative 42. They both have m's as their bases, so we're going to add their exponents. So my answer is negative 42 m. Notice I didn't write m to the first. We don't write, oh, that was not good. We don't write m to the first. We don't write 1m. Ah, this is a good one. Here's like multiple variables. This is good. This will be really good. 6 times m times n cubed times 2 times m cubed times n squared. So we want those constants. We're going to do like variables. That almost looks like a minus. So we have m times m to the 3rd times n to the 3rd times n squared. So like bases, multiplying like bases. So 6 times 2 is 12. We get m to the 1 plus 3. We're adding their exponents because we're multiplying like bases. And then you have n to the 3 plus 2, which gives us 12 m to the 4th, n to the 5th. Now, in this term, our variables should always be alphabetical order. So m is going to come before n, even though n has more numbers, or a bigger exponent. We have negative 2 times u cubed times negative 4 times u cubed times v squared. So let's put the constants together. Let's put the u's, and then v doesn't have a partner. So 2 times negative 4 is positive 8. U to the 3 plus 3 times v squared, which gives us 8u to the 6th v squared. Negative 5 times u times v to the negative 2, our first negative exponent, times negative 3 times u times v to the 4th. So we're again going to still keep those constants first. Let's look at the u. We have a u times u, and then we have v to the negative 2 times v to the 4th. That'll be fun. Negative 5 times negative 3 gives me 15. That's going to be u to the 1 plus 1. We don't see any of those, right? There's invisible ones in there. And then times v to the negative 2 plus 4. Just because it's a negative doesn't mean you change anything. You're still going to add their exponents. That gives us 15u squared v squared. That's a real good one. I like that one. 3 times a squared times 2 times a cubed times b cubed. Let's put the constants, 3 times 2. Let's put the like variables. Wow. And remember, my variables have to be alphabetical order. So 3 times 2 is 6. A to the 2 plus 3 times b to the third. It didn't have a partner. 6a to the 5th, b to the 3rd. Alphabetical order. Oh, did I? Whoops, sorry. Oh no, that worked out. Yep, good. All right, I think we'll see it on this one. Coming up. Number 25. So we have negative 4 times x squared times 4 times y to the 0. Negative 4 times 4 times x squared times y to the 0. So there were no like bases for the variables. That gives me negative 16x squared y to the 0. Y to the 0 can be simplified. We cannot leave it as y to the 0. We know that y to the 0 is equal to 1. So that sort of says negative 16 times x squared times 1. And anything times 1 just gives us our original term. So negative 16 times 1 gives me negative 16. And then you have your variable x squared. Now we move on to the division. And we have to, again, we can separate this. We can see this as negative 6 over 4. And then we have like bases. When we have like bases and we're dividing, we're going to subtract those, negative 2 minus 3. And this takes place, this is in the numerator because there's no fraction bar. So please recognize that that is taking place in the numerator. 6/4. 6/4 can be reduced by 2. 2 goes into 6, 2 goes into 4. So this becomes negative 3/2 k, and negative 2 minus 3 is negative 5. Now, really important to understand, as I've mentioned a couple times, this takes place in the numerator. We're in the numerator. So we can put that up there with the 3, which is also in the numerator. Now our directions way in the beginning, way in the beginning, that your answers should contain only positive exponents. So when we look at this problem, we see that we have a negative exponent. So in order to get rid of that negative exponent, we're going to change that negative exponent to a positive 5. And when we do that, we're going to take that base and it's going to be moved into the denominator. We're always going to change the location. You change the sign of the exponent, you change the location of the base. And that was the base of that negative exponent. Negative 3 is not affected by it. That's not attached to that negative 5 exponent. So the 2 is still in the denominator, and this becomes k to the 5th. So it went from negative to positive by going into the denominator. So that is the only answer that we will accept here. We have our fractions, our coefficients, 5/2, can't be simplified. We have n to the negative 2 minus 3. That gives me 5n to the negative 5 over 2. I need to get rid of that negative exponent again. So this base is going to go down into the denominator. 5 stays in the numerator, 2n to the 5th. And that would be our final solution. We have negative 6 over negative 6. K to the 4 minus 3. We're subtracting because it's division. So if we looked at that, we'd see the 4 minus, that division is represented as minus, and then the 3. So whenever we divide like bases, we subtract their exponents. This negative 6 over negative 6 equals just 1. So we're not going to write the 1. K to the 4 minus 3 is also 1. So I would never write 1k to the first. You would have to write just k. That k has a coefficient of 1 and an exponent of 1. So don't make that mistake. Number 29. So coefficients, x to the negative 2 minus negative 4. There's your trick question. So we have our numerator, negative 2, divided by minus negative 4. So numerator minus denominator. So 7 over 7 equals 1. We're left with x to the negative 2 minus 4 is negative 2 plus 4, which gives us x squared. Number 30, you have negative 8 over negative 6, a to the negative 1 minus 3. A negative and a negative. A negative divided by a negative is going to give me a positive, and then I'm going to reduce 8/6. 2 goes into 8 and 2 goes into 6. So 2 goes into 8 4 times, 2 goes into 6 3 times, a to the negative 4, which would give me 4a to the negative 4 over 3. Where'd those negatives go? These negatives, negative divided by a negative is a positive, so that answer became positive. And now I have to get rid of that negative exponent. So I'm going to take that base and I'm going to move it into the denominator. So we get 4 over 3a to the 4th. Last couple. We have 8 over 8. Ooh, now we have multiple variables. Good. X to the 1 minus 1, y to the negative 4 minus negative 1. Woo! We got everything here. 8 over 8 reduces to 1. X to the 1 minus 1 is 0. Y to the negative 4 plus 1. Well, x to the 0 is equal to 1. So you're left with y to the negative 3. We can't have a negative exponent, so that needs to go into the denominator. Oh, look at all the fun stuff on that. Lots of things happening there. It'll be interesting to see how many of you get 31 correct. Our coefficients, we have 3 and negative 6. We have x to the 4th minus 4, y to the 4 minus negative 4. Remember that double negative. This negative is represented by the division. So 3 over negative 6, 3 goes into 3 and 3 goes into 6. 3 goes into 3 once. 3 goes into 6 twice. X to the 4 minus 4 is 0. Y to the 4 minus 4 is 4 plus 4. So that is, we're going to put this in the numerator over negative 2. Notice the 1 dropped off because I wouldn't want a 1 up there. And then x to the 0 is equal to 1. So that's still going to give me y to the 8th over negative 2. Also a little bit of a tricky one. Now you say, Mr. Mack, I have a negative. Nope, that's a constant. We don't care about negative constants. We just care about negative exponents. Common mistake students make is they see this constant, negative 2, and they feel they have to move it up. You can't do that. We're only doing that with exponents. That doesn't have an exponent. That's a constant. And number 34, last but not least. So if you want to write this, that's fine. That negative is represented as a negative 1. We have a to the 1 minus 1, b to the 4 minus 2. That gives me negative 1/3, a to the 0, b to the 2nd. Let's write numerator and denominator. Oh, look where I moved that negative. I took it, it was up in the 1, and then I moved it down there because I didn't want to write a 1 up here in the numerator. So a to the 0 is equal to 1. That goes away. You have b squared over negative 3. Now you could have written negative b squared over 3. That's okay also. But don't give me both answers. Give me one of those two. You also could have just had, that, where the negative is outside. So the negative can be in the numerator, it can be in the denominator, or it can just be outside.